Okay, so this is section 4.6, last section of chapter 4. What? Polynomial and rational inequalities. So inequalities means we have less than, greater than, less than or equal to, greater than or equal to. So same thing we're doing, just now with an alligator eating 1/2 our equation. So the first objective is to solve polynomial inequalities. So if we had x minus 2 squared times x plus 1 less than 0, we're going to solve it by graphing. So we input x minus 2 squared, x plus 1. When we graph, we see that we know without even graphing, we know that the x-intercepts are 2. It's got a multiplicity of 2, so it's going to tap right there at 2. And the other 0 is -1, this guy. And so it has a multiplicity of 1, so it crosses. So I know we're going to come, boom, hit 2. We have a y-intercept of 4 because when I put 0 in, I get 0 minus 2, which is -2. Squared is 4, and then 0 plus 1 is 1. So 4 times 1 is 4. So it's going to come cross at -1, hit 4, swoop down, tap 2, and then shoot back up to infinity. It behaves like x cubed at the end, so it's that swimmer function, which means it starts down and then goes up at the front and the end. So it kind of looks like this. So then once we get the graph laid down, we are going to shade. We want anything that is less than 0. So where is the function less than 0? Starting at -1 and heading down into negative infinity. It's not included, so at 0, that's why there's a little hole there. So if this function is less than 0, when x is less than -1, or in interval notation, it's from negative infinity to -1. All right, so if we had to solve where x to the 4th is greater than x, we definitely want to put 0 on one side and everything else on the other. So we subtract x from both sides. Then let's go ahead and figure out the 0. So for me, I would factor this. Factor out an x, and then x cubed minus 1 is the other factor. X cubed minus 1 is the difference of cubes. And if you don't have difference of cubes, let's go ahead and highlight this. So somewhere on your paper, write difference of cubes. And I will put up the correct difference of cubes. So your first term minus your second term, parenthesis, your first term plus the sum of the two coefficients plus 1. I'll put the formula up on the board. Okay, so once we have that, we know x equals 0, or x minus 1 equals 0, or x squared plus 1, x plus 1 equals 0 are the zeros of our function. But if you look here, this quadratic does not cross the x-axis. He is a positive, he's a sunny side up parabola that has a y-intercept at 1, at plus 1, so he is never going to have a 0. So the zeros of this polynomial are 0 or 1. Then we use the zeros that we found to divide the real number line into intervals. So we know that from negative infinity to 0, something's going to happen. From 0 to 1, and from 1 to infinity, we are not included, so we cannot equal. That's why these are parentheses and not brackets. So what we do then is we test to see if we are below the x-axis or above the x-axis. So if we put in a test number and we get a positive, then we're above, and we put in a test number and we get negative, we're below. So we're going to do some testing. So from negative infinity to 0, we're going to put negative 1. When we plug negative 1 into our function, we get 2. That's positive. Between 0 and 1, we put in 1/2. When we put in 1/2, we get negative 7/16, and that's negative. Then from 1 to infinity, we put in 2. And when we put in 2, we get 14, which is positive. So then we look at our original function. We want to know where f of x is positive. We conclude that f of x is greater than 0 for the numbers where x is less than 0 or x is greater than 0. Because our inequality does not equal 2, we cannot include those numbers. We have to have a open parenthesis. So the solution set is x less than 1 or less than 0 or x greater than 1. Interval notation says from negative infinity to 0, union with 1 to infinity. Any questions so far? Pretty easy? It's taking everything we know, putting it back together. 0. Hi, sweetie. Why are you bringing me that? Is that my action item?
That's just a note for me being late.
Okay. I'll pass it along to Pate. Actually, I had no doubt that you were not feeling good.
Yeah,
So you're fine. I don't think you can fake that.
Yeah, it's like I feel fine sometimes, and then I'll just randomly have a meltdown.
And then you'll crash. Yeah. Give me my recorder back. Oh, we just recorded. Just recorded all that. Awesome. What makes our numerator equal to 0? Well, when x minus 1 equals 0, when x is equal to 1. We are undefined for x equals negative 2. So we're going to we're going to use our intervals from negative infinity to negative 2. Something's happening with our graph. Then we can't equal negative 2. So then something else happens from negative 2 to 1, because 1 is where our 0 is. And then something happens from 1 to infinity. So we're going to test the intervals, do a test situation between each one. So from infinity to this is missing a negative. Please put that in your notes. Negative infinity to negative 2. We choose negative 3, so we plug that in, and 4 times negative 3 is negative 12, plus 5 is 7, and negative 3 plus 2 is negative 1, and negative 7 divided by negative 1 is 7, and then minus 3 is 4. So we are positive in this region right here. Between negative 2 and 1, we pick the easiest number, which is 0. I put 0 into our original equation, and I get out negative 1/2. So we know we are negative between -2 and 1. And then from 1 to infinity, I plug in 2. When I plug in 2, I get 1/4. That's positive. So then we go back to our original. And we want to know where f of x is positive or 0. So we're going to take our function. So we want to know where we're positive, which is infinity to -2. And we can't equal -2, remember, so it's got to be a open. And then from 1 to infinity, and we can equal 1 because it's greater than or equal to. So we have a included 1. So interval notation says -infinity to -2, union with 1 included to infinity. Make sure you guys are grabbing your test intervals. Kind of looks like this. I would also be okay if you did open circle, closed circle. All right, and here's the summary for this entire section. And that concludes our notes for today.